In this video, we'll be seeing about how the XI protocol supports the cache maintenance operations. Okay, so first we'll just clarify something. So XI itself does not define any explicit cache maintenance commands like the clean, invalidate, or flush. Instead, it just provides the metadata and ordering mechanisms that allow the cache maintenance to be implemented by any of the agents, like high-level agents like CPU and cache controller, right? Cache maintenance is enabled, but no, it is not driven or commanded by the XI protocol. So, what exactly is needed in the cache maintenance? What are the requirements we'll see? For the cache maintenance to work correctly, the system must have and ensure that there is visibility, right? Data which is written by the CPU reaches the memory. Ordering the maintenance happens after prior writes, with respect to the scope, any the operation affects the correct cache levels and the completion guarantee. CPU knows when the maintenance is done. So AXA supports these using transaction attributes and barriers, strong ordering and completion responses. So the key mechanism used for the cache maintenance are using these two signals, AR cache and AW cache. This gives about the info about the cacheability and policy hints. These tell the interconnect and the slaves of the transaction should interact with the caches. So basically, we have these three info, right, which is given by the signals. So bufferable, cacheable, or read or write allocate policies are defined. So cache maintenance accesses are often marked as these right non-cacheable, strongly ordered, or no allocate. So this is one of the example, right, of some cache maintenance policy. So this ensure that the maintenance operation itself does not get cached. So first let's look about a strongly ordered transaction. So cache maintenance sequences require strict ordering. So the AXI supports this kind ordering using the same ID, using non-bufferable and non-cacheable, and enforcing the ordering rules within an ID. So this kind of guarantees all the previous write completed before the maintenance access is observed. So how a clean cache works, right? CPU cleans a cache line, writes it back to the memory. CPU cache control identifies dirty lines. For each line it issues a AXI write transaction to the memory, and makes AW cache as non-cacheable and AW prot as normal data. So write data goes to the AXI to memory controller, and AXI B valid response confirms completion. So this way, AXI ensures write completion and visibility. So this is how kind of a small example how the cache clean works here. Next, going on to how the cache invalidate works. So invalidate requires mainly no stale data kind of remains, and no future reads observe the old data. So typical flow is the CPU issues a barriers, cache control invalidates the line locally, and in the future reads we go back, go to the memory using XI read and mark non-cacheable if required. The XI role in this is to enforce ordering and prevent reordering around the invalidate. And going on to the barriers and fences in AXI, right? So AXI supports barrier using transaction ordering and not special opcodes. So again, using the same ID, it makes sure of the ordered completion. And then we have the non-bufferable accesses and completion wait using R valid and B valid. So this acts like all memory operations before this point are globally visible. So when it comes to the limitation of the XI for cache maintenance, XI cannot invalidate other master's caches, and it cannot broadcast snoops and track any cache line ownership. So that's why we have this AES protocol and the CHI protocol, right, for the same. So basically, cache maintenance is explicit in case of AES, but it is indirect in case of XI, and there's no snoop support or cache coherence in case of XI. And the clean or invalidate operation. So this is actually software driven in XI. In case of AES, we have it as hardware driven itself. AES basically adds the snoop channels, cache state transitions, and explicit maintenance operations. So let's say we have a problem of CPU cache has dirty data and DMA reads the memory. So in this the solution is like CPU issues a cache clean, and clean closes the XI writes to memory, and CPU waits for the completion. And the DMA reads the memory via XI, and the correct data is observed. So The AXI support the cache maintenance by providing transaction attributes, strict ordering guarantees, and completion signaling that allow the software and cache controllers to implement clean, invalidate, and variable operations, even though AXI itself does not define any explicit cache maintenance commands. So, thank you.